Numbers 21 through 24 really are very similar. It's just the application of the integral here is different for each problem. Here we're talking about the rate of consumption of oil in the U.S. During the 1980s, and we're given this function. And notice that this is a rate of consumption of oil. Now, when we integrate this rate over the time period, then we will get the total number of barrels that have been consumed. So we're going to integrate here from 0 to 10 of this function c of t dt. And when we integrate that, then we should get about 332.965 billion barrels. So the important thing is to set this equation into your calculator. And if you want to put this into y1 and then integrate using f and int, that's fine. Remember, f and int needs four things. It needs the function, it needs the variable you're using, and then we're going to integrate from 0 to 10. Number 22 has to do with the daily consumption for a particular home, and this is measured in kilowatt hours. Now, this is in kilowatts, and time is the number of hours past midnight. So what we're going to do is just integrate from 0 to 24 of that function c of t. So we have c of t dt, and if you integrate that from 0 to 24, then that turns out to be about 93.6 kilowatt hours. For number 23, these are light bulbs that are burning out at a particular rate. So if we plug this into our calculator and integrate, we are going to integrate for the time period of 0 to 100 days. And if we integrate that rate, e to the negative 0.00175 t, then we should get, here's a dt here, then we should get about 161 bulbs. And then number 24, here we have a traffic flow that's going through an intersection, and it is modeled by this function. Make sure that you are in radian mode. And so we're going to integrate 74 plus 6 cosine of t over 3 dt. And this time, notice that this is in minutes after noon. So because of the fact that it's saying that it's from noon to 12:30, our time interval then is from 0 to 30 minutes. And if this is the rate at which cars are going through that intersection in cars per minute, then when we integrate this, we will get the total number of cars through that intersection. And so that should turn out to be about 2,200 cars. This was bulbs, light bulbs, and this one turned out to be cars.